All right, here we go. Part 2, quadratic formula. Last lecture, we talked about the quadratic formula. We first have to put our quadratic equation in standard form, that is, set it equal to 0. Then, if we set it equal to 0, we can always obtain the solutions using this template. We identify a as the coefficient in front of x squared, b is the coefficient in front of x, and c as the constant on the end. X is equal to the opposite of b, the coefficient in front of x, plus or minus, take that number, square it, keeping in mind what's under the radical. First is always positive. Just this term is always positive. When we subtract this, the whole result may be positive or negative, but this very first number is always positive because we're squaring the value of b. Then subtract 4 times the leading coefficient times the constant term, all under the radical, and then divide it by twice the leading coefficient. That will give us the solutions to this equation. Quadratic formula works on any quadratic equation. That in mind. All right. All quadratic equations have either 2 solutions, they're both going to be real, or they're both imaginary. We never have one real solution and one imaginary solution. That never can happen because imaginary solutions always come in conjugate pairs. So if we have one imaginary solution, we have 2 imaginary solutions, or both of them are real, or we may have, in the last example we saw, we call a repeated solution. So given ax squared plus bx plus c equals 0, a quadratic equation in standard form. Again, here's our template for our solutions. This little chunk of stuff under the radical has a name. It is called the discriminant of the quadratic equation. So b squared minus 4ac is called the discriminant of the quadratic equation, and this will be our quadratic equation I'm referring to, and it determines the number of solutions. Number and type of solutions to your quadratic equation. Being said. Right, so I'm going to put this back up here. How about that? There we go. That looks good. All right, so this is the discriminant. Right. If the discriminant is negative, then we're going to have 2 imaginary solutions. So both our solutions will contain I, and they will be conjugates of each other. If our discriminant equals 0, then we will have 1 real solution. We can never have 1 imaginary solution because imaginary solutions always come in conjugate pairs. So if the discriminant, the chunk of stuff under the radical, zeroes out, then we will have 1 real solution. We call this solution a repeated solution. If our discriminant is positive, then we will have 2 distinct real solutions. So real meaning no I, and here we meaning when we have an imaginary, we mean we're going to see I. So we'll have, if the discriminant is positive, we'll have 2 real solutions. They both may be nice rational numbers. They will not be the same. or they will contain a radical that can't be simplified. In that case, they will be conjugates of each other. So let's just revisit the equations we did in the last section and see how this applies. So x squared plus 2x minus 5. The discriminant is going to be the b squared minus 4ac. I take that back. So b squared would be 2 times 2 is 4, minus 4 times the coefficient in front of this times this. All right, so that is 4. This becomes 4 minus 4 times 1 times negative 5 is negative 20, which is positive 24. Therefore, x squared plus 2x minus 5 equals 0. We'll have 2 real solutions. And if you go back to your notes from that example, you'll see that we had 2 real solutions. I believe it was negative 1 plus or minus the square root of 6 over 2 and negative 1. I don't remember. You can go back and look, but we did. So going into this, I would know that's where I can expect. This example, my discriminant is negative b minus 4 times 1 times negative 40. So that's negative 3. Oops, nope, don't do that. Boo, 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 boo. B squared is 9. It's b squared. So do as I say, not as I do. So b squared would be 9 minus, this is negative 160. So 9 plus 160, which is 169. So if you look at the second example, you'll see that when we did solve it using the quadratic formula and by factoring, we got 2 real solutions. Whoops, sorry. There we go. Better. All right. The third example we looked at in the last lecture, the discriminant, b squared minus 4ac. Well, b squared, b is negative 4, so my discriminant is 16 minus 4 times 2 times 7. 16 minus 8, 56. We got negative 40. So my discriminant is negative. So by those little rules, and after using the quadratic formula, we see that we got 2 imaginary solutions. So if you look back to that example, both our solutions contained I, and they were conjugates of each other. This is going to be important in our next section when we talk about graphing these quadratic equations. All right, lastly, in order to determine the discriminant, we have to put it in standard form. So I'm going to subtract the 8x from both sides and keep it in descending order. So my discriminant now I can identify as b squared minus 4ac. Well, b is negative 8. I'm going to square that. That's 64 minus 4 times 1 times 16. We get 64 minus 64, which is 0. And if you look back, we see that we got 1 solution. And it was a real solution. It's always real. If we have 1 solution, it's always real. Repeated solution. We call it a repeated solution because its factors repeat. if you notice, so let me just show you that. Here, let's take a look at x squared plus 16 equals 8x. X squared minus 8x plus 16 equals 0. You notice this factors nicely. It is a perfect square trinomial. So its factors repeat, and from those repeating factors we get the only solution. So 1 repeated. Solution. All right, kids, I think that's the end of 8.2. So you're to do, read 8.2. So you really still should be reading your text material. The exercises in the book are 1 to 69 odd, maybe every other odd. This is just tons of practice using the quadratic formula. If you plan on proceeding to Math 172 and then pre-calculus, so forth and so on, you really want to be good at using the quadratic formula. So I highly suggest doing as many problems here as you can. So now you can do your ALEX 8.2 topics. So for 1, we already decided it's going to be 20% or 5+ hours. Okay, for the 8th, we're going to go up to 60% or 5+ hours. And then the following week, you have your exam. So for 4:15, you want 100% in ALEX done. An exam for Chapter 8 is going to be on Thursday, 4:16. All right, don't forget to check Blackboard. Look under the announcements, look under the to-dos. So before you send an email asking me what the to-dos are, please check Blackboard. Most of your questions are probably answered there, so save us both the time and the aggravation of asking questions where the answers are already there for you. All right, hope everyone is doing well and staying safe. I will see you in 8.3. Bye.